welcome to our next little video on multiply and divide algebraic fractions. So remember the fun we had back in year 7 fractions. So you might have remembered at the end of year 7 you probably did a little unit where you had to learn to add, subtract, multiply, divide fractions and so on. So it's been a while since then, so you need to think back to that. So trying multiplying fractions from year 7, explain how did you multiply fractions. If you're having trouble remembering, you're welcome to pause and watch the multiplying fractions song. Or you can, if you remember, you can just write in your own explanations. So I'm going to try to write in my own explanation now, but you're probably better off writing your own, I would say. So how would you multiply fractions? I tend to say you just multiply the numerators and then multiply the denominators. Denominators. You may need to then cancel down. Then cancel down. So let's say, for example, e.g. if I do 8/1 multiplied by 3/4, I could just go, I'll show you two ways. So 8/1 times 3/4, you could just go 8 times 3 is 24, 1 times 4 is 4, and then 24/4 equals 6. You could also go like this. You could go 8/1 times 3/4, and you could cancel down. So with multiplying fractions, that's when you can cancel down like this. 8 and 4 cancels down to 2 and 1. So you can cancel vertically, you can cancel diagonally, you can't cancel horizontally. So now we've just got to work out 2 times 3. What is 2 times 3? It's 6. 1 times 1 is 1. Common error sometimes in tests, people tend to leave their answers as 6/1. What is 6 divided by 1? That's right, it equals 6. So see, we got the same answer either way. Dividing fractions. If you want to revise dividing fractions, if you've forgotten how to do it, you're welcome to stop and pause and watch the keep, change, flip video. If you remember, you can write in your own explanation or you can use the explanation I'm going to use. It's up to you. So what is a mnemonic device? So a mnemonic device is like a memory device. So like a memory device we use to remember how to divide fractions. One I tend to use is keep, change, flip. Keep, change, flip. Some people call it KFC instead. Keep, flip, change, but I say keep, change, flip. So we've got a little example again. Let's go e.g. Let's say 3/4 divide by 8/1. 3/4 divided by 8/1. We keep the first fraction. 3/4. We change to a multiply. So change can be in blue. Keep, change, and then we flip the second fraction. So the second fraction was 8/1, so when you flip it becomes 1/8. And then it's just a multiplication now, isn't it? What's 3 times 1? 3. What's 4 times 8? 32. 3/32, does that simplify? No, it doesn't. So, but we should make a note. Remember to simplify your answer. But 3/32 doesn't simplify any further, so we're done with that one. Okay, so nice little memories of year 7 and basic fraction operations. Now let's try applying it to algebraic fractions, a little bit trickier. So now the instruction will tend to be simplify. So now let's try to simplify the following. X multiplied by 5/2x. You can rewrite that. You can rewrite it as x/1 multiplied by 5/2x, because x is the same as x/1, isn't it? See, like that, same as x/1. And then you can just multiply. You could cancel down first if you want. I'm going to do without cancelling down to actually I will do with cancelling down to begin with, and then on the left I'm going to show you without cancelling down. So with cancelling down, because it's multiplying fractions, you can cancel down like this. We can cancel down an x, and if you cancel down that, that becomes 2 times 1. And then what's 1 times 5? 1 times 5 is 5. 1 times 2 is 2. So our answer is 5 over 2. If you weren't to simplify, you could just write like x over 1 times 5 over 2x. You just have to, if you want to cancel down, sorry, then we just have to simplify your final answer. So in green, I'm going to do the non-cancelling down version. So that would equal 5x over 1 times 2x. And then notice you would just have to remember to simplify that answer. It equals 5 over 2. Both methods are fine. Some people, and remember it's only with multiplying that we can do this kind of diagonal cancelling down or vertical cancelling down. We can't do horizontal cancelling down. It's only when there's a multiply in between the two. Some people are confused and think when it was x over 1 equals 5 over 2x, they could cancel down, but they can't. That was the mistake that Groot made in the previous lesson, or the mistake that you made that Groot got angry with, if that makes any sense. Okay, so x over y times a over b times y over 3a. I'm going to do the cancelling down method first, and then again I'm going to do the non-cancelling down method. So the cancelling down method, I've got to cancel diagonally. Let's see, I can cancel an A and an A. Divide off the A here, you get 1. Divide off the A there, you get, on the other side, you get 3. Can I cancel anything else diagonally? Yes, I can. I can cancel a Y. Y and a Y. And that's enough cancelling for now. Can't be bothered doing any more. So now we've got x times 1 is our numerator. And denominator will be 1 times b times 3. So 3b. Can that be simplified any further? No, it can't. So that's our answer. Now let's try it without simplification, without cancelling down, sorry. So we would have x times a times y would be axy. And y times b times 3a would be 3aby. And then you would have to cancel down after that. So we can cancel a and a. We can also cancel y and y, which would leave us with x over 3b. See, we get the same answer. Same version, the same answers. Same with this one. Just different ways to get to the same answer. Then we've got 3 over 2g cubed. If you're having trouble remembering how to do ones like this, you might want to consider writing them all out again. So as in like writing them all out in their entirety, like 3 over 2g times 3 over 2g times 3 over 2g. That helps. Why not? So equals 3 times 3 times 3. Would you agree? It's 27. 2g times 2g is 4g squared. 4g squared times 2g is 8g cubed. Can that simplify any further? Like, is there something that goes into 27 and 8g cubed? No, there's not. I can show you how we would go straight to the answer. So we can go straight to the answer if you just use your exponent laws. 3 to the power of 3 would become over all of 2g to the power of 3 using exponent laws. And then that becomes 3 cubed is 27. 2g cubed, 2 cubed is 8. G cubed is g. Sorry, g cubed is just g cubed. There we go. So we've got the same answer either way. Loveliness. Continuing on, we've got a divide now, so just be careful, like things might flip between multiplication and divide. Keep a keen eye on what the operation is. So we've got 9 over h divided by a over h squared. So on the previous page, what did we do for divide? We'd use the mnemonic device, keep, change, flip, or whichever method you've got, it's fine. So that means we keep 9 over h, we change the divide to a multiply, and we flip the second fraction. Before we do anything, don't do any cancelling down before you've done a keep, change, flip. You need to keep, change, flip first. Then, because it's now a multiply, it's possible for you to do some cancelling down. So let's see, I'll try the cancelling down method on this side. I can cancel horizontally because I've got an h here and an h here, so that leaves h. Divide both of those by h, you get 1 and h. Then you can multiply the top. Numerators, 9 times h is 9h. multiply the denominators. 1 times a is a. Let's try it without that little cancelling down method. So you would still get 9 over h times h squared over a. So remember, you still have to do keep change flip. Then you would just multiply. 9 times h squared is 9h squared. H times a is ah. Then you would have to cancel down anyway. So you'd have to cancel down that, which would leave an h behind. So it equals 9h over a. So see, both methods got you to the same answer. Okay, cancelling down sometimes is easy. You just have to make sure you do it correctly. Because if you cancel down correctly, then you don't have to deal with any simplifying. Or very unlikely you'll have some simplifying at the end. You might still, you'd have to double check. So we've got f over p over ab, fp over ab, divided by p cubed. How do you write p cubed as a fraction? You just write it as p cubed over 1. Nice. Now let's start to do our keep change flip. So we're going to keep fp over ab. We're going to change the divide to a multiply. We're going to flip the second fraction. So instead of p cubed over 1, it's going to be 1 over p cubed. You could do some cancelling down if you want. You don't have to. I might be lazy this time, and I might not bother even to cancel down. So fp times 1 is just fp. And then ab times p cubed is just ab p cubed. Now I just have to remember to simplify my answer. I can divide off p and divide off a p, which will leave p squared. So that would leave us with f over ab p squared. Pretty weird answer. That's what it is. Yep, I think that's right. Good. The other alternative, I could have cancelled down in that top step. I could have cancelled down p from fp and a p from p cubed. But, okay, so now let's go into this one. We've got a divide, so we're going to need to keep change flip before we do any cancelling down or anything like that. So go 6x plus 30 over w. Notice it's capital W, so use uppercase W. Change the divide to a multiply and flip the second fraction. A squared over 2x squared minus 50. So some interesting stuff kind of going on. What you might want to do is you could just go straight to multiplying out the numerators and the denominators. You could also try to see if there's any common factors or anything like that as well. Let's maybe do that. I'm going to see if I can factorize the top. This is just one way you can do it. So I'm going to, looking at the numerator of the purple fraction, what is a common factor? Have a think. Let's write it 6. So I can take out 6 as a common factor, and what would that leave in the brackets? That's right, that would leave x plus 5 all over w. Still multiply. A squared on the top, nothing exciting there. But 2x squared minus 50, let's see, is there a common factor there? That's right, there's 2. 2 brackets, what would be inside the brackets? Correct, that would be x squared minus 50. That might not look too exciting, but have a look at, it's not x squared minus 50. What did I do wrong? That's right, it's x squared minus 25. That's better. Now, what I just have in the green bracket in the denominator, what's special about that quadratic expression? I think that's right, it's a difference of squares. So now on another whole new line, I'm going to write it out with that quadratic factorized. So we've still got, I need to write a bit to the left, 6x plus 5 going on here over w. Still multiply by a squared over 2. Oops. And how would you factorize x squared minus 25? That's right, it's a difference of squares, so you go x plus 5, x minus 5. How about that? And now can you see anything that can be cancelled down? Like can you do you don't have to cancel down immediately, you could if you really wanted to. Just multiply the numerators, multiply the denominators, and then cancel down. So if you prefer to do that, go ahead. I'm going to cancel down at this point already though, because I like cancelling down with multiplying fractions. So what can I cancel down diagonally? Can't cancel down anything vertically, and you're not supposed to be able, you can't cancel down anything horizontally. That's not supposed to happen mathematically anyway. But we can cancel down something diagonally. What can we cancel down? That's right, we can cancel down x plus 5. Fantastic. So now our expression is looking a bit more simple. We've got 6 over w. Taking a lot of steps to write this out, sorry. Over a squared, 2 brackets x minus 5. And now, it's probably a bit easier now, I personally find anyway, to now multiply the numerators and the denominators. So equals 6a squared over, let's say 2w, x minus 5. Do you see what I did with the denominators? Instead of writing w2 x minus 5, we tend to write the coefficient first. So 2w x minus 5. You could have also written 2 brackets x minus 5, close brackets w, but I just think it's nice. Can we cancel down still? Have a think. Always good to not feel too satisfied and think that you've finally hit the final answer. That's right, we can cancel down 6 and 2. 6 and 2 cancels down to 3. So our final answer so far is 3a squared over, the 2's now gone, w x minus 5. So who would have guessed that the division at the top would end up with an answer like this at the bottom? So it's all about kind of cancelling down and realizing that you can quadratic factor and find out more factors that can cancel down and make it more simplified. Okay, groovy. And that's the end of the lesson. Thank you.